Hey physics friends, Mr. Collier here. Today we're going to wrap up Chapter 5 by feeling the power of the dark side. We're going to talk about power. Power in physics is the rate at which you do work or the rate at which energy is transferred. So it's basically how fast work gets done, how fast energy gets used. So it's really just work divided by time. It's a scalar quantity, as is work, meaning direction is not something that comes into play. Now, since work is equivalent to energy, we can also equate this to energy over time. And since work is force times distance, we can say it's force times distance over time. And we can rearrange it also to come up with power equals force times average velocity, since distance over time is speed. The SI unit for power is the watt, named after James Watt, who developed the first steam engine. 1 watt of power is the power equal to 1 joule of work done over 1 second, or 1 joule of energy transferred over 1 second. Because this is a fairly small amount, we will very often talk about kilowatts when we talk about the electrical energy. And you'll notice that as you eventually go to pay an electric bill. Now, in British engineering, we tend to use a horsepower, which is equal to 746 watts. Because Watt's steam engines were replacing horses, horsepower was developed as a way to compare these modern vehicles and these modern engines to the work done by horses in the past. So typically, horsepower is going to be used for larger machines, whereas watts for smaller things. So you might talk about a 100-watt light bulb, which would only be about 0.13 horsepower, and so that doesn't really make sense. Whereas you might talk about a car engine being 100 horsepower, just because it's such a higher number. So here's a sample problem. If a crane is capable of lifting a metric ton, which is 1,000 kilograms, vertically 25 meters in 9 seconds, how much useful work is done? So we're simply going to figure out force times distance over time, and our force is going to be our metric ton times gravity, and we can solve for power. And then we can also convert that from power in watts to horsepower. When talking about power, we can also talk about the efficiency, which is a percentage used to describe the amount of work, energy, or power put out by a machine compared to the energy that it consumes or that you have to put into it. So we can describe this as work output over work input, energy output over energy input, or even power output over power input. So say, for example, a crane has a 70 horsepower motor. How efficient is that same crane? Well, we just figured out that it was putting out 36 horsepower, so we can divide those and figure out that it's 52% efficient. Most cars are actually only about 30% efficient. Bicycle is much better in the 90s. But many things we use, especially as we turn electrical energy into things, a lot of heat is wasted, and so the actual efficiency is fairly low. And so that's it about power. Nice short one today. Good luck. Let me know if you have any questions.